Hey everyone, welcome to the first video in our series on the reactions of chapter 14. In this video, we're just going to be worried about ethers and specifically how to cleave ethers. And that's mostly what we're concerned about in chapter 14, but we're also worried about epoxides as well in chapter 14. So next video is going to be talking about epoxides, but in this video, we're going to be talking about cleavage of ethers. So ether cleavage. So ether cleavage is not too bad. We're going to need to know the mechanism for this, and that's kind of the most important part because the actual reaction is fairly easy, okay? So all I really do is I take an ether, like this one, and I use HBr, or HI, or HCl, right? I can use any of those three. I use HX, right? I just use acid. And then what this does, if I use enough HBr, it literally cleaves the ether. So I'm going to be cutting the ether in half right here. Okay, so I have 3 carbons on one side, and then I have 2 carbons on the other side. And then where it was bonded to oxygen, I just replace it with a bromine on both of them. So I've taken 2 carbons and then put bromine there, and then 3 carbons and put bromine there. So these are the 2 products that I make from this reaction. Okay. So again, not too bad. It's literally just cleaving the ether and taking it and cutting it in half, right? We can do other examples as well. So something like this, if we take this, we can use HCl and cleave this. And if we cleave this, if we use enough HCl, whoop, that's not what we would get. Then we, again, cleave it down the middle right here, right? And then on the end of this bond, we put a Cl. And then on the end of the other bond, we put a Cl. Then we just need to make sure to count our carbons and everything and make sure that we have everything where it needs to be. Okay. So again, we'll do one more with HBr, or excuse me, with HI. So we cleave it here. So on one side, we have 1, 2, 3, 4 carbons. Put an I. And then on the other side, we just have, it's just a methyl iodide, right, that we'd make. So as far as products go, this is all we're getting, right? This isn't too complicated. It's pretty simple. The only thing that we need to know that's even slightly complicated is the mechanism, okay? And the mechanism is going to kind of depend on what we're using, okay? So I'm going to do the mechanism for this first one. And I'm also going to do the mechanism for this second one here, okay? I'm also going to do the mechanism for the second one. Okay, so the first one, all right. So the mechanism, and like I said, this is an important mechanism that I would definitely internalize. So the mechanism for this first one. Gotta check and make sure I'm drawing it right. Yep, I wasn't. Okay. So we're gonna do the mechanism for this one, and then the mechanism for the other one. Okay, so in this mechanism, the first step is that this ether is going to attack this HI, HBr, HCl, right? So in this case, we used HBr. So the ether is going to attack the HBr. So we have HBr in solution. And it gets attacked by the oxygen on this ether. So it takes the H off, and then that bond leaves, okay? So now what that gives us is an oxygen that's protonated. So it has a positive charge. And then I also get Br minus, right? Okay, so I have this in Br minus. So now here's the thing. this Br minus is going to want to do SN2, right? It's going to want to do SN2 to get the other group off, right? So what happens is the least substituted carbon, so this connected to the oxygen. So this oxygen is connected to two carbons, right? It's connected to this one on the left, and it's connected to this one on the right. Whichever one is least substituted, the bromine is going to attack there, SN2 style. So it attacks on this carbon, and then these electrons go onto the oxygen. So what that gives me is it gives me an alcohol. Gives me this alcohol, right? And then I also get my first alkyl halide that I had written earlier, right? So now, sometimes if we just use one equivalent of HBr, sometimes we just end up with this, right? Because we need another equivalent to get rid of this OH now. So assuming that we have enough, assuming that we have excess HBr, or two equivalents, or however much we would need, now what happens is this OH is going to get protonated by another HBr. So OH gets protonated. Just one pair of electrons, sorry. So now, since this is a 2-degree group right here, this can just leave and follow an SN2 type of mechanism, right? So this is going to leave, and that's going to give me a carbocation. Gives me this carbocation, right? And then Br minus can come in and attack. And then that gives me my final product, which is this one. And here I also get water, right? So you can see that my two products are this one, which I drew earlier, and this one. Those are my two products, okay? So here, as you can see, that after this gets protonated, the least substituted carbon is going to get SN2 style attacked. If this is primary, right, this is primary, so it can get attacked. However, here, this didn't get attacked, right? Since this is 2-degree, 2-degree and 3-degree, it's going to go through an SN1 type mechanism. So this is going to leave SN2, SN1 style, and then I get a carbocation. So now I want to do an example where we will just have SN1 style leaving, and we won't have any SN2 style backside attack or anything like that. So let's take a look at the mechanism for one more here. Okay, so the other one that we had written was this ether. So again, first step is the same. So HI is going to lose a hydrogen to the ether. And then I also get I minus, right? So now if we look at this, we have a 3-degree and a 2-degree. Neither of those are going to necessarily want to go through a SN2, right? So what's going to happen is the more substituted one is going to leave, all right? So the more substituted one leaves. So in this case, the more substituted one is going to be this one. So these electrons are going to go onto the oxygen, okay? And then what that gives me is this alcohol. And that also gives me a carbocation, a 3-degree carbocation that looks like this, right? Whenever that leaves. So now this 3-degree carbocation, we can have an I minus come in and attack this 3-degree carbocation, no problem. And then that's going to give me one of my products. So I'm going to draw that product over here. So it gives me my tertiary iodide, right? But here with this OH, what can happen is now this can get protonated by an HI. And this is also going to go through an SN2. So OH takes a hydrogen off, I leaves. And then I get a protonated alcohol with I minus. And as we know, protonated alcohols are good leaving groups, so that's going to leave as well. And then that's going to give me a carbocation right there. And I also get water. So now, as a final step, the I minus that we just made is going to come in and it's going to attack there. Oop, attack there. And then I make my alkyl halide. So this is one product. This is my other product, okay? So again, all of this just depends on, you know, what degree everything is. So in this case, both of these were 2 degrees, so we're not going to have any SN2. If we have 1 degree, then we'll have SN1s, or if we have 1 degree, then we'll have SN2. Excuse me. But in this case, they both went through SN2 type mechanisms or SN1 type mechanisms. I'm sorry, I'm messing this up completely. Let me rephrase. This one here, since both of these, right? This carbon here is a 2 degree, and this carbon 3 is a 3 degree, right? So this is 3 degree. This is 2 degree, right? So since that's the case, this is going to prefer to go through SN1 both times. Whereas in the last time here, if I take a look at this one here is 2 degree, and this one here is 1 degree. So this one prefers SN2 because it's 1 degree, and this one prefers SN1 because it's 2 degree. So a lot of 2s and 1s and everything, so it's a little tough to keep track of all of it. I get that, but yeah. So that's kind of what we're worried about. Okay, and then, you know, as we said earlier, these would be our products if we had these. Okay, so I did this mechanism with HI, and then I kept this with HBr. So yeah, like I said, I do believe this is a pretty important mechanism, so I would certainly know how to do this mechanism. So yeah, hopefully this video is helpful. The next one we're going to be talking about a lot of different things with epoxides, so that's going to be important. Hopefully you'll stick with me until then, and if that is the case, then I'll see you next time.